Welcome everyone. In this video I am going to prove that we can represent cosine of x in terms of e, Euler's number, using such a relationship. So I claim that cosine of x is equal to e raised to the power of I times x, and I here is defined as the imaginary unit. It is the square root of -1. We have this plus e raised to the power of negative, this time I times x, divided by 2. I claim that this is correct. But how can we check this? It doesn't make it correct just because I said so. And to check this, we will use Euler's formula. And I derived Euler's formula in one of my previous videos. You can access it from the cards right now. So, Euler's formula tells us, and let me separate this. Euler's formula tells us if we have e raised to the power of I times x. I believe I made the proof for I times theta, but of course replace x with theta. Replace theta with x, I mean, it doesn't matter. This is equal to cis of x, and cis is just an abbreviation for cosine of x plus I sine of x. And you can see where the abbreviation comes from. C stands for cosine, I stands for I, S stands for sine, and X stands for X. So this is Euler's formula, which, as I said, I proved in one of my previous videos. You can watch that proof. I think it is very elegant. So how can we use this to be able to derive our claimed actually formula, this one? Well, I want to first express this guy e to the power of ix and this guy e to the power of -ix, and then I'm going to sum them, then divide them, and let's see if I get cosine of x. If I do, all great, that formula is correct. If I don't, well, still nothing has changed. It's just that my claim was wrong. So we already have, by the way, what e to the power of ix is. So let's just find what e to the power of -ix is. So let me write e to the power of -ix. Well, it will be equal to, using the general formula, using Euler's formula, it will be equal to cosine of, well, how can we think of this? Perhaps think of it like this. Let me do it first like this. Think of it as we have e raised to the power of I, and then we have -x. Okay, so we would have cosine of -x plus I sine of -x. Okay, and using your sum and difference formulas for cosine and sine, you might be able to, actually no, you can't find this, what cosine of negative x is using those, I believe. But what you can do is, you can think of your unit circle. You can think of your unit circle, and the x will give you cosine and the y coordinate will give you the sine. So if this is the angle x, this would be the angle -x. And you can see that since cosine of x is like this, the projection over the horizontal axis, cosine negative of x is equal to cosine of x. So this part is equal to cosine of x. We have plus I, and when we look at sine of -x, we see that since it is the projection over the vertical axis, if we project it like this, we see that we get the negative of sine of x. So it is negative sine of x. And now we are able to write our initial statement, the right side of it, and see if we arrive at the left side. So we will have e raised to the power of ix plus e raised to the power of -ix divided by 2. And for e raised to the power of ix, we substitute Euler's formula. So we get cosine of x plus I sine of x. This is, as I said, e raised to the power of ix. Then we have a plus here. And now we substitute for e raised to the power of -ix. And as we showed it here, it is equal to cosine of x minus I sine of x. I just pulled this minus here. So this is what we have for e raised to the power of negative ix. Then this is divided by 2. Alright, and we see that negative I sine of x and I sine of x, they cancel, they add up to 0. So on the top, on the numerator, we have cosine of x plus cosine of x, which gives us 2 cosine of x divided by 2. And if we divide by 2, if we simplify by 2, we get cosine of x. So it is indeed correct that this expression involving Euler's number, the exponential number, and I mean, the imaginary unit. So it involves Euler's number, and it involves I, the imaginary unit, the square root of -1. This expression actually gives cosine of x, and it can be quite helpful in some cases in physics or in other areas, I believe. So I just wanted to prove that it is indeed correct. I hope you found this video helpful. If you have any questions, please write them in the comment section. I hope to see you in another video. Until then, take care.